All right. Let me know if I need to speak up. I'm known as a yeller, so I can always be louder. All right, so today we're going to be talking about regular expressions. If you're kind of confused right now, it's because you're probably here for the machine learning one. That's going to be in like 30 minutes to 40 minutes, and Dan Drews is going to be giving that speech. So just to start out, I'm Sam Kirkland. I'm one of the devs here. I'm on the code health and architecture team, so I do a lot of refactors. We have roughly 1 million lines of code, so I touch almost all that code every once in a while. So a lot of that involves automating stuff because I don't want to have to manually do it. So that's kind of where this talk came from. I use regular expressions every day to do that work. So here's a summary of what we're going to go over today. We're going to talk about what regular expressions are. We're not going to go into the implementation details of them because you can go ahead and implement the regular expression spec in any language. So it's different on every language and even on different versions of every language. So it's not super useful. We're going to be talking about some real world examples. That's going to be the fun part. And then we're going to be talking about when you should not be using regular expressions because there are some pitfalls of it. So to start us out, just to set some expectations, I'm not going to be showing any .NET code today. I'm going to be showing examples in JavaScript. The reason for that is because the tooling around JavaScript and regular expressions is really nice. What I normally do is I write all my regular expressions in JavaScript using the tools I'm about to show you. And then, like I said, you just implement the regular expression specs in any language. So you can pretty much just copy and paste that regular expression anywhere, and it's just going to work for the most part. Again, it's a really good idea to use the tools available to you in JavaScript. There's just websites out there that do almost all the work for you. It doesn't make sense to pull out Visual Studio a lot of the times when you're trying to test this stuff out. So to start us out, can everybody hear me okay? First of all, we're good? All right. So regular expressions, really there's two parts of every regular expression. The pattern, and that's the actual regular expression. I'm going to abbreviate it from now on as Ragexr. The pattern is the Ragexr, and then you perform that pattern against a string. So in this case, we have the regular expression up top, and then below we have the string that we're trying to match on. In this pretty simple example, we're looking for all A through Z characters, uppercase and lowercase, and then that plus says how many of those do you want to match. And it says between 1 and infinity. So what that's saying is it's looking for anything that's an alpha, anything that's A through Z, uppercase or lowercase. So that's why you see that the groupings aren't pulling in spaces, because that's obviously not an A through Z. And we're going to dig deeper into this example right now. So this is one of the tools I use. It's called Ragexr. I'm going to zoom in for you guys. And this website starts to break down a little bit if you change the normal zoom level. So hopefully this works out. I don't want to go any farther than that. Okay, so here you have the regular expression, and this is where I'm talking about the tooling. So .NET doesn't really have any built-in tools to help you modify regular expressions. This is using JavaScript regular expressions, and if you hover over any pattern in our Ragexr, it will show you what it's doing. So in this case, it matches any character A through Z, and then lowercase A through Z, and then if you hover over the brackets, we can see it's matching any character in the set. For you programmers out there, that's the equivalent of me kind of doing an OR between these two. It's just convenient to have it all next to each other. And then the plus is our quantifier. So that's saying match one or more of these instances. And in these parentheses, every time you see a parentheses, that's saying I want this as a group. I'm going to be using it. I need you to save it as a variable. So what regular expressions do is it grabs that, whatever's in that group, and it's going to give you it as a variable. So in this case, we can see all of our capture groups right here. Over here, this is the output. So $ is how you access all the results of the regular expression. The ampersand in JavaScript is how you get the entire matching group. That means the entire string it performed a match on. $1 is your first group. $2 would be our second group. We don't have one in this case. If I wanted to get one, I would just add another parentheses. And you can see there's no matches. And then the final part of this is the flag set. G just means, hey, I'm looking for multiple instances of this, so don't just stop at the first one and give up. So if I go ahead and I remove this G, you see it only finds the first word. It's going to run till it finds a match, and then it's going to stop. Okay, so here are the tools we have available to us in regular expressions. Obviously, I showed you A through Z. That gets really tedious typing that out every time, as you can imagine. So the short code for that is just W. And what this means is any word character. And then if you see an uppercase W, that means negated. So anything that's not a word character. D is digits, same as doing 0 through 9. Capital D, no digit. So what's not a digit? Any special character, any space, stuff like that. S is white space, so tabs, returns, spaces. And then capital S, obviously not white spaces. And then one thing that kind of trips people up is this dash can be used for anything. So I could do A through G, and it would match any of the characters A through G. If I only wanted to match 7, 8, and 9, I could do 7-9, and it would get 7, 8, and 9. And then quantifiers, that's how many of the previous match do you want. By default, it's always 1. It's required. So let's say I want to make that optional. You're writing a regular expression, and you want to see if your string contains the word color, but you also want to support Europe. So color could have a U in there. So in this case, you'd write the regular expression, you'd write color, and right after the U, you'd put a question mark. And that says, hey, that one, there can be 0 of them, there can also be 1. So now it works for multiple languages. The plus, we use that already. That's 1 or more times. It's required, but you can also have unlimited of them. Star is 0 or more times. That's saying it's not required, but they could also have unlimited of them. And then this is n number of times. So in this case, I have X. So let's say I want to get all zip codes from a string. I can go ahead and say, I want to get all 6 character zip codes, and I say 6 in there, and it's going to match all digits that are 6 characters. No 5s, no 4s, no 7s. And if I go and do it again, let's say I want 6 or more character words. So I do W, and then I say 6, comma, that says it has to be 6, but it can also be bigger than that. And then again, this one, you see where this is going, between the 2 numbers. Brackets, we already went over that. That's basically saying an or, any of the characters within the brackets. So it's going to do an or operation for you between all of those. The caret and the $ are special. So if you're writing software for a newspaper company, they generally have like a special font for the first word in the newspaper article. You know, the has a fancy font and it's bolded. You easily want to do that with regular expression. Super simple. You do the caret sign. That says the first, the caret sign is matching the beginning of the string. And then you can do W, and that's going to give you the first word character. Exact opposite with the $, that's going to match the very end. So let's say you're writing something for your code and you want to make sure everybody's ending their line with a semicolon. That's how you do it. Okay, so then flags, we already went over G, that's the global match. By default, it's only going to match the first occurrence, and then it's going to stop. You can see without the G flag, it's only getting the word the. We add the G flag, now we have multiple matches. Then there's the I. I almost always include I. That's case insensitive. Most of the time, you don't really care about case. Then you don't have to go through the work of adding the uppercase and deal with all that. And then the last one is M. I really don't like how they name this one M. It's pretty confusing. So what really that's doing is it's modifying this caret and this $, and it changes the way they work a little bit. So instead of caret meaning the beginning of the entire instance of the string, it's the beginning of that line and the end of that line. There are some gotchas with that one. I would just probably stay away from M. You almost never need to use it. Okay, so the things we aren't covering in this talk, just because we simply do not have time, is there are some other flag options. Most of them are for Unicode character support. I've actually never even used them. I've just never needed to. Back references, You can do some really complicated stuff with regular expressions, especially with like lookarounds and back references. Those are definitely advanced topics. You can Google them after this talk. Some of the tools I use every day, obviously Visual Studio. There's this really nice extension called Select Next Occurrence. I will show you an example of that in a second. If you get nothing out of this talk, I would just go, the next time you get into work, I would download this extension. It will speed up your day, and I can show you why. I call it like poor man's regular expression. So there's Visual Studio Code, Chrome Devtools, Sublime, Atom, all these editors support this. It's normally hotkeyed to Control D, and it supports multiple cursors, and I'm going to show you an example in a second. It's not technically a regular expression, but it'll let you automate your job a lot. And then Notepad++, I'm going to show you an example of that in a minute, but first I want to show you Visual Studio. So I have multiple occurrences. Let me zoom in real quick. I have multiple occurrences of this orderable, and I want to change that. It turns out we did a rename. Visual Studio can do renames in JavaScript, but it doesn't do a great job. If I want to go in here, I can randomly, I can go and change this manually to like filter, but now I have to copy paste this to every line. Instead, I can click Control D, and it's going to automatically select all those for me, and then I can just type the new word. So this is multi-cursor support. It supports unique clipboards for every single line. So I can go in here, and let's say I want to copy this property value and I want to include it in the filter name or whatever. You can see the clipboard is unique for every single occurrence. You can also, with this extension, you can add cursors manually if you wanted to do that for some reason and type things. Again, just trying to reduce that really repetitive stuff. So that's what I call like poor man's Ragexr. So like an example of doing that in VS Code is this is just like a dir listing of every file on my desktop. So let's say I just want like the file extension of all of these files on my desktop. I can just go in here, I can select all these values. I'm gonna just hit the N key and then Control Shift back, and now I have the file extension of every single file on my desktop. And then again, that works with basically every editor nowadays. Chrome Devtools supports it. So you can open up Devtools, and if I have like test equals test, you can see I click Control D, and now it's going to be editing multiple things at the same time. And then Notepad++, Visual Studio crashes a lot. We've all had it happen. It happens a few times a day for me, for some reason. So if I open up Notepad++ and I click Control-Shift-F for search all files, you can do this find in files, and then you can tick regular expressions. That's a little hard to see, but then you can actually run the regular expression on an entire folder. So you can just select your source control folder and you can run it, and then you don't need to deal with Visual Studio maybe crashing or being really slow. Another tip to doing that is you should always set a filter on which files you'll be running this on. By default, it's every file. So it's going to be running this on JPEGs, on binary files, on any zips you have in your solution. Obviously, that's going to be really slow, especially if they're gigabytes. So like, let's say you're running a cleanup on just CSS files. You should do star.css, and then that'll speed up your query a lot. And then the final two, these are two websites. I'll be using this one extensively throughout the demo today. It just lets you test your regular expression without starting the debugger a lot, using like edit and continue a lot. Because there's no compile, it's all runtime. So it really speeds up the development. Okay, so here are some real world examples. This is going to be the fun part of the talk, where we actually get to do some code. So the first thing we're going to be doing is finding actionable items, and then I'm going to show you an example of just a basic code refactor that we use regular expressions for. The first thing is just an example I saw just last week was I have two-factor auth on all my apps that I use, and I get text messages, right? So something I noticed was the default Messenger app in Android actually prompts you to copy two-factor auth codes if it notices they're there. So all I'd have to do is click this copy, and it copies to my clipboard. It's really convenient, and they did this. Their source code isn't open source anymore, but I imagine they're using a regular expression. So here I have an example of, let me close that. So here I have an example of some two-factor auth codes. I just Googled two-factor auth text message, and I just tried to pull in as many examples as I saw so we can try to support all of the text messages. So let's say we're writing a text message app. We want to compete with Google, so we want to have that really nice context stuff in there. So the first thing I would do with regular expressions is one of like the rookie mistakes I see people doing is they write one regular expression to do everything. What you should really do is write multiple regular expressions, and we'll get to that later on in the talk, but it's a lot more maintainable to maybe run one regular expression that says, okay, is this message even something that I can work with? And then if that's true, then you can go on to your next one, and that actually pulls out the data you need. So in this case, I want to pull out and see which of these text messages I can do two-factor auth on. So I want to do a grouping, and then I would go in here and I want to look for the word code. Oops, that's all uppercase, so that's not going to find any matches. That's actually a great example, so I'll type code uppercase, and I'm just going to set the flag to case insensitive. So you can see that actually captured all four of them, which is good. Let's make this a little more bulletproof, and let's change that and do an or clause, and let's also match the word, if I can type, verification. And then I would go a little step further and do like auth and maybe like factor, because those are common words they're going to be using in the messages they send you. So once you run this regular expression in your code and it returns a result, then you know that it probably has a two-factor auth code in there. So then you'd run the next regular expression, and in that case, we want to actually grab these codes from the text message. So to do that, we need this grouping again, and we're just going to do the digit. So you can see it's capturing the digits now. Now we might be done, but if you notice, it's capturing each individual digit occurrence. And if I turn that G flag on, it would only be the first one. What we want to do is we really want to group every single digit together. So I can add a plus after that, and you can see now these are grouped together. Now a lot of you noticed the problem already. Any other number is going to be captured as well. So like the number 5, now in my code, how do I know which one's the two-factor auth code? Is it 5? Probably not, that's not super secure. It's probably this one. But instead, let's just change our grouping so it just excludes those. Another example would be like, you have 15 minutes, right? We don't want to really capture the 15. So instead of that plus that says 1 to infinity, let's change it. And let's say, let's require it to be 6 digits. So now if you hover over this, you can see it has to be 6 digits. Now I did a bit of research. Most of them tend to be 5, 6, or 7 digits. What we're gonna do is just add support for 5 or more. So now it's gonna go loop through everything. If it's 5 digits, if it's 1,000 digits, it's gonna try to grab it for us. If I wanted to do 5 through 7, that's all I'd have to do. So now you can see it's grabbing all of them. And if we go down the list, you can see each key.
Question about that.
Yep.
So if you're matching the 5 to 7, or this is really a question that's if they like put your phone number in there without dashes, so attention number, you would actually match that as 2 groups.
Yep. So his question, just for people who can't hear, is what happens basically if somebody puts a phone number in. So like, let's say you have a really weird service and they say like, if you have questions, call me, right? So now you have a phone number in there and it's gonna try to capture that grouping. What you can do in this case is really, we could filter out like anything with dashes in it, because normally you have phone numbers that are like formatted with dashes, and we could like filter that out. Exactly. We could filter that out. We could also do something like this. Because this is a big string in here, we could say, hey, let's require white space after it, and let's require white space before it. So you can see now it's not capturing that because there's no white space separating it.
I really like \b, just the word boundary.
Yep.
Then it could be at the start of the string.
Yep.
Not require any space.
Yeah, so \b does end of word boundaries, yeah. Yep. Was there another question over here? Yep, yep. You guys are going to the advanced topic stuff. We're not getting into that today. So next up is finding actionable items. So with that same example, you get a text message in Android and iOS. I'm sure they do this too. So Google will go ahead and recognize phone numbers, email addresses, websites, and even more complicated things like addresses. And you can just click on that item and it'll open up Google Maps, or you'll click on it and it'll open up your email application. So let's try to do that. Click. So again, here's the text message you saw in the previous example right here. So let's try to underline the regular expressions.info and the phone number as well. So we have the G flag on. Let's turn the case insensitive flag on just in case. And what I would actually do at this point is I would write two regular expressions, one to get the phone number, one to get the domain name. So let's start with phone number. So you just do digits. Again, you have the same problem. You could go and say it needs to be in this exact format. It needs to be 3 digits. Then it needs to be dash. It needs to be 3 more digits, a dash, and then 4 more digits right there. But now you're kind of locked into this situation where it has to be in this exact format. If you have a user add, a space by accident, or they format it nicely, it's not going to work. Same with country codes like that. So what I normally do is I get the basic case working, and then obviously you build off of that. So I just try to put as many examples together as I can of everything I could possibly think the user could be doing. So they could put all the numbers next to each other. They could have them all separated by dashes. That's probably good enough for us. So let's modify this regular expression to work with all of it.
The third one's missing. Third one.
What's wrong with this one? Oh, thank you. Perfect. Oh, I have insert on. Okay, there we go. So we want to make this a grouping, obviously. So to just build off of this, we really probably don't want to change this because there should always be 4 digits in that third block. We can make these dashes optional by just adding that question mark. And you can see, obviously, it's saying it's optional now. So if we do that, we now have this one and this one. So progress. Another step, we could add the parentheses and make those optional. So you can see I can add parentheses around this one. And now if you hover over it, there's 2 groupings. It's because parentheses by default are going to do another grouping. So I need to escape those. And you can see this is saying capture group 2. So let's just escape that real quick. And now it's not working at all because there's this dash here and it's expecting a dash or no dash. So if we did this, now it would work fine. So really what we want to say is expect a dash or expect white space. So now it's capturing that and it's capturing this one up here, but we broke these 2 down here. And that's because it's always looking for these parentheses. So we just need to make those optional as well. We add question marks to them, and now those are optional. So we're pretty good at this point. The last thing you'd probably want to do is add support for the country code. Sometimes they have the plus, sometimes they don't. What you'd really want is a space and then a single digit, and then you want that all to be optional. Oops. And you can see we're pulling in everything now. Any questions on that?
Is there a way to make that more readable, or is that supposed to be readable?
It's very difficult to read regular expressions. We'll get to maintainability later on, but some languages do support some features that make it a lot more readable. But yeah, they're really hard to read. I kind of use the example as regular expressions are like CSS. they're easy to write, but the second you leave and come back, you don't know what the heck's going on. So you have to comment them. There are a few things you can do. One of the things I like to do is split them up into multiple regular expressions, not trying to do everything at once. And then you can say var email regular expression. And then you just put it in there. Somebody might not be able to read what that's doing, but they know what it's trying to do, match emails.
If you're skilled at Ragexr, can you read that?
You can read it, but there's always like that doubt in your mind where you're like, this is either matching phone numbers or I'm an idiot. Like,
If it's something you're going to be using for a long time, you probably want to put it in a function and write units.
Yep, definitely. And then another great thing about this tool is if you click over here, there's this community section. This will actually show you, so there's everything you could ever be writing has already been done for you. So like if we go in here, there's US currency, just tons of work that the community's done that you can go ahead and load up. And then obviously this isn't super readable, but you know that if I wasn't zoomed in a lot, that it would be capturing that stuff. Yep.
What's the difference between \s versus the actual white space character in the red text?
So \s is any white space character. So a space, it has to be a space. \s could be a space, it could be a tab, it could be a return. It's generally best practice to use like \s. What I normally do in all of mine is, nope, that definitely got deleted. I do like a star at the end because maybe the user accidentally clicked like space twice. Maybe they use tabs or maybe they use spaces, you never know. So this is the code refactoring example. We actually did do this. It modified thousands of files, tens of thousands of lines. So in this example, we're just talking about vendor prefixes. If you don't know much about front end of websites, when browsers used to add support for features that weren't part of the spec yet, like let's say border radius, right? It just curves the border of like an element. So you want your border of a div to kind of look rounded. You know, you have the Web 2.0 look. You want rounded corners everywhere. You want to use that, right? But you can't because it's not part of the spec yet. So what the browsers did is they hid them all behind their own flags. So WebKit, that was for Chrome and Safari. They looked for WebKit stuff and they implemented stuff that you had to use WebKit for. Mozilla, so Firefox obviously, Microsoft and Opera all had their own. So what you ended up doing was every time you wanted to do anything, it should have been one line, but it ended up being 15 because you had to add all these browser prefixes. You can actually go to this Can I Use website and search anything up here. So this is like border radius, and you can see, let me zoom in a little bit. You can see the global support is 94.4% for border radius. Now, take this number with a grain of salt. It's actually higher for that for most of your users. A lot of this is, so this is global usage, obviously, right? So it takes into account like mobile users and then like third world countries and everything like that. So normally it's a lot higher. You can actually change it to show like just US and stuff like that. That's what I normally do. And then you can see unprefixed. This is talking about that browser prefix. So by adding all this extra code, and this isn't even all of it, by the way, I cut it down to fit it in the example, but all we do is we gain 0.03% of our user base. And you can go in here and you can see exactly which browsers support it and which browsers don't. So in this case, we made the decision. We said we only support the latest browsers -2 versions. We're going to go ahead and then the worst case scenario is they just don't get rounded borders. It's not a huge deal. It's not like the app's not going to break or anything like that. So we decided let's go ahead and delete the code. So we ended up using a regular expression. And you can see this is going to be the more advanced one, but we really wanted to group and capture everything that started with a vendor prefix. So to start that, you obviously do a dash in your grouping. And then we wanted to capture WebKit, or Mozilla. I don't have the examples for like Opera on here and Microsoft, but we captured those as well. And you can see we're starting to capture this. Now here's another problem. We have two groupings again now. We don't really want two groupings. We kind of want to do a find and replace all of the occurrences of these browser prefixes with empty character. So it just deletes them for us. So what I normally do is if I have multiple groupings and I only want one, but you need the order of operations of parentheses, you can do what's called a non-capture grouping. If you hover over this, you see it's capture grouping number 2. So let's go ahead and do a question mark and a colon. And now if you hover over it, it says it groups multiple tokens together, but it doesn't actually capture anything. So if you hover over these, we are back down to one grouping. So then if we continue, we have another dash, and then we don't really know what else could be there. They could have spaces in here. They could be a bad dev, and they could be using like spaces instead of tabs. So we really have to be kind of as loose as possible to support everything, so we don't end up having to go back and run this 5 different times with, supporting spaces, supporting tabs, supporting both pixels, percents, EM, inches, stuff like that. There's a lot of different things they could be doing. So try to be as loose as possible a lot of the times. So now we want really everything after that. So to do that, you do the dot character, and that matches everything. So every sort of character except a new line. So I do star, and I say get everything, and dot star, you'll see it used a lot. What that means is it says get the rest of the line. Because obviously it's going to match everything except the new line, so it's just going to keep going until the end of the line. So you can see at this point we've got a pretty good match. It's going to be capturing all of the vendor prefixes. It leaves our non-prefixed one alone, which is exactly what we want. But at this point, if I copy this regular expression, I go to our code and I Control-Shift-F. I just do find and replace with nothing. I could run this, but we probably don't want to do that because it's going to replace all of these with just an empty line. So you just have a tabbed in empty line. What we really should capture is everything before it. So we want something like that, so we don't have these empty lines floating around. And to do that, you can just go over here and we can say get any white space, and then star will get everything that's white space. So you can see now it's doing multiple lines and it's capturing everything. And at this point we look pretty good. There is one last bug with this, and that's if the dev wasn't really properly formatting their CSS, they could go in here and they could say, and I want the background to be green. So now what we're doing is we're actually doing a breaking change, because we're going to capture this green and we're going to delete it as well. So what we can do is we can say, hey, go ahead and match everything until you see a semicolon, because they have to use a semicolon to separate properties. So you see if I add that semicolon in there, absolutely nothing happens. And the reason for that is by default, regular expressions are greedy, which means they're going to see the semicolon and they're going to be like, all right, I see that semicolon. I'm going to keep going and see if I see another one. And then it sees this one and it's going to be like, I'm going to take as much as humanly possible. So it takes both the semicolons. What you can do is you can say, hey, I actually want you to be lazy. Once you find the first semicolon, just stop. So to do that, you just do a question mark after this 0 or more operator. And you can see if you hover over this, it says now it's lazy. It's going to find the first occurrence and it's going to go ahead and quit. So at this point, we're pretty good. And this is roughly what we ended up running with in our app. I think we had a few more edge cases in there, but it was all just improperly formatted stuff, like lack of semicolons and stuff like that.
Background's going to be placed next to class though, right?
Yes. So part of the problem was exactly that. What we ended up having to do was just go in and manually add the return because it was improperly formatted to begin with. Yep. Can you speak up? Oh, so his question was, does JavaScript have named groups? No, but they are adding support for it. So there are polyfills right now where you can use them with like third-party tools. It's part of the ES7 spec is named groups. It makes it super maintainable. So like I could just go in here and name this group. Like the current spec calls for this format. So I could call this vendor prefix like that. And then it's going to go ahead and I can use that as a variable now.
Question mark.
Oh, it is question mark. Okay. Yeah. Yeah. Yeah, it is. Okay. Yep.
You said that you had other edge cases and that you use this on lines. How did you, what techniques did you use to find the edge cases?
Yep. So his question was you had other edge cases and you ran this on like tens of thousands of files. So like obviously we want to flush those out before we check this into production and everything. What I ended up doing was I ran this on about 50 files. I just ran it on a folder using Notepad++. So I picked a folder and I was like, all right, let's do it. This is really old legacy code. It's probably the one that's going to have the most problems. And then I just manually looked through those files. I found the edge cases. I updated the script, undid the changes, then ran it again. And then what ended up happening is we ran this on all files. And then I think Dan Drews, you code reviewed it. How long did it take you?
Not a short amount of time.
Yeah. So the code review ended up taking longer than the actual work. And that actually ends up happening a lot. But it's better than the alternative, which is looking at 10,000 files manually. Any other questions on this?
Now, the example that you looked at was specifically for border radius, but your change was to get rid of everything.
Correct.
Not just border radius.
Correct.
You did a lot more research than just looking at border radius.
Yes. So I went to Can I Use and I looked up like the 15 occurrences we had. I actually wrote a regular expression to pull in every vendor prefix we use. Our biggest one was border radius. We used transition a lot as well. So like WebKit, transition. And then we wrote the regular expression where it worked with all of them. So ended up removing all of them. We decided we were okay with removing all of them. Some had more support than others, but we decided all of them were just, it's CSS obviously, so none of them caused any major changes. We were okay with all of them. So regular expressions obviously aren't a silver bullet. You shouldn't just go home and be like, I'm going to use it for everything now. There are situations you don't want to be using regular expressions for, and I will talk about those now. So emails are crazy. The spec for emails is insane. If you ever want to spend a few hours of your free time reading something super boring, email is someplace you should look because it was made obviously a long time ago and they basically support everything. So you can see all of these are valid emails, 100% valid. You can do an IP address. If you do an IP address, you can use brackets around it. And then when IPv6 came out, they were like, we might as well allow that as well. So they threw that in there. You don't need a top level domain name. If you're like on an intranet site, you could have your DNS resolve that. So it basically allows a lot more stuff than people think, especially when you do like double quotes, you can use special characters. So like that double quote and then bunch of spaces, that's a valid email address. So writing a regular expression for this, I did not write it, I just Googled it. There are the most popular regular expression Stack Overflow post, like the top 5 are all about emails. And if you want to see some more really crazy regular expressions, and somebody hinted at it earlier, it's a really good idea to like test your regular expressions. And Google does exactly that. So here, Google has a bunch of valid email addresses. So like this one, yep, we're good to go. That's valid. %@com.com. Yep, that's okay. Nothing. I don't know. That's okay. Apparently, I don't understand that one. So obviously, there's a bunch of weird ones. I'm not even going to get into the Unicode ones. You can have emoticons in your emails. Yeah. Well, we won't get into that today. So here is the regular expression that follows the spec. So this in your code, nobody's going to understand what it means, obviously. So you really shouldn't be using this. And a lot of the Stack Overflow posts hint at this. They're saying, well, here's the answer you want, but here's what you should actually do. If we remove the edge case of double quotes and allowing special characters within the double quotes, this is the resulting regular expression. So you can see we cut it down by a ton by just cutting out the double quotes edge case. So what should I do instead? Kind of my go-to motto is when faced with a tough problem, make somebody else do the work for you. You shouldn't be writing these regular expressions to begin with. You should try to Google around, obviously. They're going to have more edge case proof solution than you anyway. So like for emails, you should just be using an HTML5 input type email. Those test cases I showed you in Chrome were actually the test cases for this type of email. And then if you need to modify it at all, you can actually specify patterns in HTML5 as well. So like this pattern right here will be a text box and it'll allow digit characters and it has to be 3 or more digits. Otherwise it's going to give you a validation error. And what's amusing is this email field doesn't actually follow the spec. If you look at their documentation, the browsers all kind of met together and they decided the spec was a little too insane to support. So they call it willful violation of the specifications because they didn't even want to support all the edge cases because frankly, some of them are a little ridiculous. Another thing you shouldn't be using regular expressions for is security scans and parsing JavaScript. This is valid JavaScript. Does anybody want to tell me what it does? You know already, that's cheating. So this actually alerts out 0. It can do anything. So this is base 6 encoded JavaScript. So eBay, the developer who made this encoder actually broke through eBay's security scan because they were parsing your JavaScript and they had like a whitelist and a blacklist. All these characters were on their whitelist. So he went ahead and made a script that let you execute anything on any eBay page. So what you can do, the name is a little inappropriate, but that's okay. What you can do is you can go in here and type any JavaScript. So I can say alert, test. I can click encode. All you have to do is run this. You don't have to eval it or anything, and it's going to run that JavaScript. So don't use regular expressions for security scans, SQL injection, stuff like that, cross-site scripting especially. All the person needs to do is find one way around your scan. Really, you should be using regular expressions for code cleanups. You can use it for HTML as long as like it's your HTML, so you know it's going to be properly formatted. I'll get to that in a second. Just do not use it for security scans. And I talked about that. You should really be writing like using a parser, and then you should have a whitelist, and then you should be good to go. And then another thing is non-regular languages. Most of you have probably seen the funny Stack Overflow post talking about this, but HTML is not a regular language. So it's impossible to write a regular expression. Like mathematically, it's impossible to write a regular expression that can cover all the cases that HTML can cover. It gets even more complicated when you realize that every browser has its own implementation. So I can write invalid HTML and I can publish it on a server and it will run and it will work, even though it's not valid HTML. And every browser has their own implementation, and every version of every browser has their own implementation where they think, oh, I think this is what he meant. Oh, he didn't put a double quote there. I'm just going to go ahead and put a double quote there. So you would have to obviously re-implement all of their code for every browser and maintain that, which is impossible. And then, of course, every time you change the doc type, all their implementations change as well. This is kind of bonus stuff. So maintainability, I talked about most of this already. They're obviously really hard to read. One of the things that's coming out is named groupings. That will help a ton, especially if you have a really complicated regular expression with multiple groupings. Some of the people ask questions on more advanced topics where you get a lot. If you use the built-in tags, it helps a lot with readability. I just didn't want to get too in depth. And then using multiple regular expressions as well. You don't need to put everything in one. A lot of the times it can actually be slower if you do that. Yeah, that's pretty much it. Are there any questions? Yep.
Is there any good like learning resources online that you know of that help you practice and like study?
Yep. So he asked if there's any good learning resources. There are a lot. So that website I used in the text message is an actual website. That's a really good one. They have a lot of introduction courses. If you were kind of bored by that stuff, there's a few regular expression games where it's like, try to find this match within 30 seconds or like the aliens will destroy you and the aliens are like coming down. You know. That one's too stressful for me. Yeah. Any other questions?
You never know, that might happen in real life.
It might happen in real life. Yep, definitely. There's a X case, whatever that comic thing is. There's a yeah. There's a comic exactly on that. Aliens are invading, and like I think that's what the game is based off of. But yep.
So I've had a use case in the past where I needed to check if a string existed within a certain pattern in a bigger chunk of text. So I had to build a regex pattern on the fly. So I just wanted to tell everybody to escape whatever you're putting into your regex. Otherwise, people put regex special characters in there and they both blows up.
Yep.
And
Yep. So regular expression injection. Another security thing. Great. Is that it? Anybody else?
That's actually related to something I was going to mention. I believe that .NET Ragexr methods, they have overloads for timeout penalties. You have an expression that's running away.
Yep. Yep. Exactly. And so he's saying they have a timeout option in the .NET, so you can say like only let this run for a second and then just fail. That is a really good point. A lot of the times those timeouts will happen. Like in my personal case, every single time it's because I did a greedy match. So I did .star, and it was improperly formatted HTML. So they never had like an ending div tag, and now it's searching the rest of the document. So almost always it's just me not thinking, oh, let's only look for the first 100 characters and then just quit out. Yep. One more.
So if you know anything about like performance considerations using like the regex class in .NET, to say find something that is XML file versus just doing other things with the serializer, difference between that?
So parsing XML is going to be faster than a regular expression depending on what you're doing. Is that the question basically?
You know, whether it, I guess, do you want to use regular expressions when there is a more specialized option?
Yeah, so you should, so yeah, that's a good point. He's saying like, when should you use regular expressions if there's like a more specialized option? You should probably be using like an XML parser if at all possible, whenever you can. That's just going to end up better, especially if you're doing this in the code. Obviously, you're not going to have as many weird problems. And then, yeah, like speed-wise, it obviously depends on your regular expression, depending on what you're doing. I just generally try to do best practice, which is use a parser whenever available. Yep. All right. I think that's it. Yep, one more.
In that CSS example, is it just an example or do you guys run that in CSS?
So I ran that regular expression I wrote, more or less I ran that.
Is that do you guys, as a code review, do you guys run it on the CSS or is it just an example?
I ran that CSS basically, more or less.
I mean,
Yeah, yeah.
Communication or like just for
Sorry, it's hard to hear you. What?
so like just for cleanup, code
Yeah.
cleanup.
Yeah. Yeah, it's almost all of these are for code cleanup. Yeah, one time. It's not like we're running them on every build or anything like that. Yeah. Okay. I'm over time already, so I'm going to pass it over to D'Andrews.